we will talk about in-place analytics today with unified data access. Some of our marketing folks would like to have the title of data lakes, but I thought we're going to be a bit more technical. And an important aspect today is, how you access data, how you access data with Hadoop, how you have accessed data in the past, and how to combine these things to get to a data lake. And therefore I have chosen this title. So I think this is the warm-up slide you see in any slide deck, so I will rather skip because we have only 40 minutes. We all know, data growth is dramatic. There is a lot of initiatives, top initiatives in companies to start analytics, to start using the value of the data and so forth. I mean, that's the basic reason why we are here today, right? So, so if you look at the data itself, then we still have a lot of, presentations about, data silos and how to break up data silos and why that is important. And, this picture illustrates a bit our view that in the past, we had some, I need to go back because it's automatic animation here. So we have had traditional data sets structured with databases, sometimes some log files, which we have rarely looked at, some real, office or whatever kind of data. And then we have the emerging data on the right side, which we call the data from the third platform, if you will. That's social media, that's unstructured data, that's local data, that's media data, and so forth. And these things, of course, get together, and we want to correlate new data with traditional data. And, traditionally, or at the beginning, we have seen a lot of data silos. We have to copy them together to be able to analyze and correlate the data. And we thought that, this approach requires really a data lake, there's her name again, a data lake kind of solution where you could centrally access the data rather than copying data around. And we will also discuss why that is an advantage to have a central data repository for the data. And the solutions that we deliver in this space could be virtual, could be physical, could be converged. There's some discussions around could be virtualize the Hadoop infrastructure. There's a very good white paper out on this topic from Adobe. They have used VMware tooling and Isilon as method to virtualize their Hadoop environment. You can Google it, or if you are interested, come to me and I give you the white paper. So whatever we have, you can have it in a virtual, in a physical, or even in a converged manner. We'll come back to this later on. Well, today we will very much focus on what we call the data lake foundation. That means a layer where we store the data and make it persistent. And that has a number of positive side effects. And basically we have two solutions. One is about, scalar object and Hadoop or HDFS. And the other, which is Isilon, is scale-out file and has some object functionalities as well. It scales up to 50 petabytes. So if you will stay with the acronyms, Isilon will be the data lake solution, and EMC Cloud Storage, which is geoscale object, would be the data ocean solution to build a very, very big data lake. However, the philosophy and these things that we discuss, you know, are common for both platforms. So it doesn't matter so much, and I will have some examples from one and from the other platform. If we go to the technical details, there are slightly differences in the kind of how things are implemented, but the general aspects are pretty much the same. So if you look at how in the BI world, how we typically worked in you know, together with the philosophy of we need to bring the data to compute, has ended in a lot of data silos. It has ended in, you know, we needed to copy data around, and it's also very, very hard to manage. And you know, you can imagine that's a very complex thing. You know, mixture of proprietary and new architectures, and we don't think that this is the right approach to do. So, and to give you one example of the, you know, disadvantage of this approach is if you want to analyze a data set of 100 terabytes, for example, and you need to copy it to your analytics platform, it'll take 24 hours even if it's a 10 gig E-link, right? So, which is pretty much standard. And so you lose a lot of time in just copying data around instead of doing the analysis. So imagine on the right side, and that's the solutions that we offer, you have the data in place already and can start right away to analyze it. You save a lot of resources and money to do it. And this was just one aspect of it. So this would then kind of be the new picture of using a data lake approach to analyze data, which is more like bringing the applications to the data, right, rather than the other way around. And this has multiple advantages, as we will see going forward. So it's a lot easier to manage. Government processes will be much less complex, and so this is the way going forward. And you have seen a lot of, you know, presentations around these topics, bringing data together and you know, towards a data lake. One of the solutions I mentioned that we have in this space is Isilon. Isilon is a scale-out NAS system which does exist since 15 years now. It's a very scalable, scale-out NAS system. Historically started with NFS, then we added protocols as we go. And today we also support HDFS access to the very same data. And we will see in a couple of minutes how we have implemented it. So, but first of all, let's just have a quick look to the architecture and the idea, let's say, on Isilon and how it has been built. So both of our solutions, or basically everything that we built today, follows the idea of scale out, because there is no way anymore for a storage system to have 1 or 2 or 3 controllers. So Isilon has been built from the beginning as a scale-out architecture. We use Intel servers with internal disks, just like a traditional HDFS implementation. And then there are some slight differences in that we have a integrated dual redundant InfiniBand for the backend, and I explain you in a minute why that is, but that's nothing that you need to manage. You get this as an appliance, and then you can use it. So the front end is 1 gig or 10 gig Ethernet. We have 4 ports per node, and that's basically it. So the most important idea of Isilon is that we have combined the RAID layer and the file system and the volume manager together in one system. As a result, as an administrator, you don't need to deal with RAID arrays, with volumes, with file systems anymore. There's just one very big file system that spawns across all nodes in the cluster. Nodes range from, we start with 3 nodes, and currently we do support 144 nodes, which is equivalent to 50 petabytes of storage capacity. You can access the very same data through NFS, SMB, FTP, HDFS, and so forth. Well, one thing of Isilon is that data gets distributed automatically by the system in the background. So you don't need to care of where the data goes. It automatically gets distributed across all disks in the system, across all nodes in the system. So they fill up equally. And if you want to add nodes, you just add a node, and then the capacity is available right away. Of course, there's a rebalance of the data that happens automatically. That's a background job that you can control, but usually you don't need to care about this. So that's and at the same time, you can decommission nodes, if you will. Same thing, it's a push button kind of thing. You say, hey, I want to decommission this node. Then a background process starts, which decommissions the data from the node. And then once that's done, you can remove the node. It's quite simple. Well, as I said, and that's now also important with respect to HDFS, how we distribute data and how we protect data in the system. So once you write a file, and with Hadoop it's traditionally 64 megabytes, then we have a traditional file system size of a block size of 8K. We put 16 blocks together and make it a 128K stripe size. And we distribute that across all nodes and disks in the system. And that's one of the differences to HDFS, where you have a single file and you write it to a node, or you read it from a node, but you read it from one node. In case of Isilon, you distribute it, so you write it to one node, but the data in the backend gets distributed to all nodes in the system, which is, of course, much faster, as we will see going forward. And for this distribution, internally, we use the very fast InfiniBand network. Also, it has some impact on how we protect data. You have seen already, we also built parity stripe units, and we will see this later on. But now let's look at how we did implement HDFS in that picture. So basically, we have implemented a daemon that runs on every node of the system that speaks HDFS. So we have implemented HDFS as a protocol rather than a file system, because we have had this file system since a decade or so with all the functionalities that we still miss in HDFS. Meaning, what I said, distribution across all nodes, being able to do snapshots, being able to replicate, all these nice things that we know from enterprise storage system. So this daemon then translates the HDFS RPCs to POSIX system calls, and since the protocol is stateless, the file system handles a coherency in the background. This also enables us to very much and very quickly adopt to new HDFS versions, because we just need to change the protocol aspects of it. So you will see that Isilon is very, very close to the newest HDFS version that's out. So sometimes it comes out at the same time. Sometimes we have a couple of weeks delay, but you can this is one of our priority, to be very close to the newest, because we know that this evolves very quickly, that we are very, very close to the newest HDFS version. So how does these things work in terms of the data flow? Well, you have the native Hadoop node, and there is just one place in the config files where you just say, hey, there's the name node. So that's pretty much very, very quick to integrate Isilon in that equation. And then, since the name node runs on all nodes, it's not only active, it's active on all nodes, so we have no single point of failures in this case. And you can round robin the request, or we do round robin the request to all nodes in the front end. So any name node can respond to requests and can, place the client to the right node where the data blocks are. Other than with a traditional Hadoop, every node can serve any request. However, we will look at that, the response from the name node is pointing to a rec local node to serve that data, to be as close to the data as possible. However, that is not required in general. So because, every node has access to the whole file system space. So if you look to the traditional way of how you ingest data, there is very basically 3 steps. First, you need to stage your data, and then to a landing zone, and the next phase is you copy the data over to the Hadoop cluster, where you most of the time have 3 copies of each blocks, and then you can do the analysis on the data. And well, another step would potentially be to copy the results back to your traditional file system. Well, with Isilon, you pretty much can sometimes remove even one step or ingest the data over any protocol you want to, right? So there's no requirement anymore for having a specific staging space, because you can ingest to Isilon from any source to any node. It's very fast, and we will see some slides where IDC did some performance benchmarks and compared it to a traditional implementation. And then you can start doing analytics right away on your living data, or you can use snapshots to do the same thing. And there's also use cases that we are building up demos for our EMC world, where we really show use cases where data is ingested via NFS, then it's accessed via object, OpenStack, Swift, and analyzed at the same time. So that's really a cool feature that you can, you don't need to copy data around to access it from multiple sites. Well, let's look at some performance figures compared to a traditional implementation. This would be the picture for a traditional Hadoop architecture, where, first of all, typically the ratio between storage and compute is fixed. Right? You have so many disks per node, and then, if you want to add capacity or add compute, you have to add both, and memory, of course. Then the non-local HDFS I/O comes through the Ethernet, of course, and the local disk, are used for shuffle IOs. And if you look to the IO stack of this implementation, then considering that 10 gigabit Ethernet is a standard today in data centers, we are heading towards 40 and 100 gigabit Ethernet and so forth, but 10 gigabit Ethernet is pretty much a standard. Then you can really see where the bottleneck is in this implementation. So it's the disk rather than the network. So the initial philosophy from probably 10, 15 years back, we need to bring the data to compute is not true anymore in any case. So so in this example, if you have 12 internal disks, you end up with 600 megabytes per second, and that's the maximum you can get out of your disks. And the network is not the bottleneck in this case. Well, how does it look with Isilon? As I said, we have a backend network where we distribute the data. Still, the HDFS traffic comes into the front-end Ethernet, and on the local disk, which we recommend still to have some local disk for the shuffle data, is then, so the I/O is not shared anymore with on HDFS IOs and shuffle IOs. So you use some internal disk for the shuffle, and the rest goes through Isilon. If there's a request, then Isilon collects all the data through the internal InfiniBand, and then delivers it to the client or to the compute node. And well, if we look at this stack again, you can also see that, you know, Isilon with a 10 gigabit Ethernet, I mean, that's a requirement to have massive throughput. We can deliver roughly 750 megabytes per second per Isilon node. We have some different nodes, but this is kind of the working horse, if you will, that's used more often. So here is some data from a telco customer that tested Isilon against the traditional architecture and did some TerraSort tests. And this is, you know, the results out of it. So if you only look to the compute phase where you really process the data, we are roughly 2 times faster. And in addition, you save a lot of time for ingesting the data, assuming that it is already on the platform. There is another performance validation report from IDC. They did quite the same thing, which is documented in a white paper that you can download. If you Google it, you will find it very quickly, or you drop me a mail and then I can provide that to you. And, you know, first of all, they tested the ingest with NFS. No surprise that we are significantly faster, because that is what Isilon has been made for traditionally. Very, very big throughput, massive kinds of parallel data ingest or even read. But also for the HDFS jobs or for the Hadoop jobs, Isilon is between 1.5 times and 2.6 times faster. Well, there is, you know, always the question of, is that apples to apples and so forth. As I said, details can be seen in that white paper. The test has been based on a 7-node cluster, 7-node DAS cluster, and a 7-node cluster with Isilon as the storage backend, if you will. Another performance validation has been made by the ESG group. So that's also publicly available if you Google it. Pretty much the same results, ranging from 20% to 100% faster. They did use the converged infrastructure solution that we offer with a vBlock. So the whole stack of storage and compute. So let's look at some capacity utilization in data tiering protection. How is the data protected? Because as I said in the beginning, we don't have RAID arrays and so forth. So how do we protect data? So first of all, we have a number of different node types in Isilon. I don't go into details. Upper left is very fast and a bit more expensive. Lower right is very dense, very cheap storage nodes. And how could you leverage these in an Hadoop environment? Well, like with all other use cases and industries that use Isilon, we can tier data based on policies. So one example is you could say, hey, data that's not accessed for 30 days goes into tier 2. This is a node type that's a bit slower, but bigger disk, higher density and so forth. And other data that's active still remains in the fastest nodes. However, the data from the logical perspective is still at the same place. So it's transparent for the applications. And you can manage that by any policy or any metadata that's available. Not only access time, you could use size of files, type of files, ownership, whatever is available in terms of metadata from the files can go into the policies. You could even extend that and say, hey, I have even bigger nodes for very long-term archive, potentially to replace data that's on tape, or to replace the tapes that hosts data that we need for long-term. But you know, instead of having them just on tape, and the only use case you can cover with it is a restore, probably you want to analyze or access the data. This would be the way to do it. And in addition, we have now a possibility. We're running that currently in beta, and that will be GA'd at in the third or fourth quarter, to use the same policy set to pool the data to a cloud provider or an object storage. So that could be another Isilon system, that could be an ECS system, that could be whatever going forward, right? So this is quite cool. And you know, how do we protect data? As I said in the beginning, we do erasure codes across nodes, so you can configure it in any way you want it to, and you can change that dynamically instead of having whatever n+2 in case of a RAID 6 array. You can do n+2, you can even do n+3, n+1, whatever you want. You can change that on directory level. You can also change that on the fly. And, oh, that's one slide ahead. And depending on your settings, you have some overhead, of course, for the data protection. That depends on two things. First, it depends on the number of nodes that you have. That's obvious. 6 + 2 is not so efficient as 8 + 2. And then also on the protection level itself. In general, we can say that the overhead that we see in real implementations is about 20 to 25%. So now think about how you do it in a traditional HDFS environment. You copy each blocks 3 times. It's much more overhead, much more disk that you need. So, and with ECS, the other very large solution that we offer for geoscale, we even extend that philosophy. So one aspect is how you could do it, or how it is done in the industry, is you just copy a block. That's very fast, but very inefficient. It's very fast because you don't need to calculate a parity, or you don't need to do a parity calculation. Then the other extreme would be you could do erasure coding and do that distributed. That is very efficient because you save a lot of space, but it's relatively slow and has some other side effects also. If in a failure, if you have a disk failure, then you need to go over the WAN to reproduce the data. And with ECS, we have implemented a hybrid model that marriages the two good things of both worlds. So first of all, when we write the data, we do 3 blocks. That's for performance. And we do it in chunks of 128 megabytes. And once a chunk has been full, then we start erasure coding on that chunk. Right, so that's the second phase then. So we get the performance out of the copying process, but at the end of the day, we do erasure coding, and we do also distributed erasure coding. So the effectiveness or the utilization rate that you get is, increases with the number of locations that you have. So it starts being really good at 3 locations. Going forward, it's even more effective. So, and that achieves almost the same rate of efficiency like the pure geoscale protection. With that, you can really build, so with ECS and that kind of data protection and distribution, you can build a global namespace kind of thing, which we call the data ocean, if you will, because that extends a typical data center implementation, as I said. And again, that is something you very much know from cloud providers. So that's object access. We do support all common object protocols from OpenStack Swift, Amazon S3, Microsoft Azure. So it should pretty much fit for every applications that you have. And then let's look at multi-tenancy. So typically you might have multiple customers or multiple departments in your company that would like to share some stuff but have requirements for data segregation somehow. With Isilon you can do that, not on a user base, but on a, let's say, departmental base. So you could create what we call access zones for different departments or different customers that you have, and say, hey, what is an access zone? That consists three things. First of all, an IP pool, so that's the segregation on the network layer. Then it requires a root directory, because I said we don't have multiple file systems, we have one. Well, we can still segregate data in that we assign a root directory to an access zone, and no one in that access zone can go back to the root level. And then you can assign any authentication provider to each access zone, or even multiple authentication providers for each access zone. So each department, each company might have their own Kerberos, LDAP, or Active Directory authentication. So that's three layers of authentication, of segregation and security. However, on the back end, we keep the philosophy that we distribute the data across all disks, which is very fast and very efficient, as I said. Well, with ECS, that of course requires a more fine-grained multi-tenant capability, because you might have hundreds or even thousands of users or groups, and so we can create different namespaces. Well, like you know it from cloud solutions, every object then gets IDs to and tokens to which that belongs. We deliver also a self-service portal with a solution. That means, pretty much from what you know from public providers, you can provide your customers with a self-service portal to provision storage. So one thing which is very important, in addition to just having the data at one place and having a better governance and having a more efficient storage utilization, is this. Since we have implemented HDFS as a protocol and not on a file system layer, we can support multiple HDFS versions at the very same time. So think about migrations. You need to migrate from one version to another. There is no need to touch the data. It's persistent in Isilon. You can just upgrade your compute nodes, all of your compute nodes, or some of your compute nodes, and access the very same data. If you want to roll back or have legacy applications that still require older versions of HDFS, no problem. We support them all. Once we support a new version, we still keep the old versions protocol support. That's a real advantage. At the same time, I say that again, you can access the data with any other protocol as well that you know from the POSIX world. And now think about how much different databases you have in your company. Well, you don't have only Oracle or only DB2 or Microsoft SQL or MySQL or whatever. So there is typical some historical reasons that also depends on application support. So we do think you may also end up most probably having different distributions of Hadoop going forward in the future, because one might support something better than the other. One specific applications that you buy requires a specific Hadoop version. So it might be difficult to stick to one. However, with this solution, it doesn't matter, because the data is persistent and you can scale your compute very independently. It's very fast. And you can use distribution X together and Hortonworks tomorrow, that would work. And even, you know, at the same time. And you can access the same data with other analytics tool as well. Like Splunk, for example, or SaaSgrid or whatever. So to just summarize with respect to Isilon some functions, just let me see if I forgot something to mention. Simultaneous access, different protocols, I've mentioned that already. Oh yeah, we do support deduplication, of course. We have a compliance mode where you can say, hey, I have some applications or some business requirements that force me to lock the data for long-term retention in a compliant manner. We can do that. If you have a directory on Isilon, you can say, hey, lock the data after three days, not having been changed. You can say, hey, lock that and keep that for 10 years, 30 years, and you cannot remove it. So it's a warm solution. That's very easy. As POSIX compliant, you can, and that's one of the biggest things, you can scale compute and storage independently. If you need more compute, buy more compute. If you need more storage, buy more Isilon nodes. Yeah, it's compliant with, you know, almost all Apache-based Hadoop things, pretty much everything that I can imagine except MapR, because they have an own file system, if you will. We do encryption with self-encrypting drives, which is very fast. I mean, that's not a software solution. That's based on the disk hardware, which is pretty much without any performance penalty, if you will. And we have a lot of enterprise functions that are not supported in HDFS right now. Okay, but you know, we were talking about a lot on storage today, and it's just to mention that we do support and we do deliver a whole bunch of other things on top, so you can have a complete business data lake solution, everything pre-installed, racked, and pre-tested from EMC that supports the Open Data Platform, that supports various distributions of Hadoop and delivers Open Analytics Toolbox, the platform manager. So if you look to the presentation before in this room, you know, you could see that it's very important that you look at and you manage how you ingest the data to the platform, and the platform manager very much helps with this. Okay, so thank you very much for your attention, and we have 2 more minutes to get questions, if you have some. Please.
I have several questions.
Yes.
So basically they're from the different areas. The first, how you address like data locality problem. For instance, you're storing data on one node, and you will be processing data obviously on a different node outside of the clusters. The first. The second, how you were addressing, for instance, upgrades of the Isilon file system.
Okay.
Should it be in place upgrade? Should it be transparent upgrade? What's the certification path with the vendor? For instance, if you're going with a new solution, there is a big chance that vendor will not be seamlessly supporting you. And the third question is, you mentioned the feedback, you mentioned 10 gigs. I know the marketing meaning of the 10 gigs links, but in reality, in my experience, I haven't seen the bandwidth between the node more than 600K. It's less than 1 gigabit link. Can you answer this question?
Sure, I will try to. So, first of all, the certification thing. We are pretty much certified with all common distributions, except MapR, as I said, because that's not based on the Apache implementation. And we are working very closely with Hortonworks, for example, to get new things out at the same time. And you know, going forward, it might happen that you need to wait for a week or 2 or even a month. That can happen. But we are very much aware that this is the fastest evolving thing currently in the industry. So we are pretty much at the same level from the support point of view. Second, with the upgrades. So the upgrades for Isilon are, we do rolling upgrades. So that means we can say that it's non-disruptive, right? So we do upgrade node by node. And once a node needs a reboot, then IP address fails over. That's a cluster, right? Fails over to another node and, you know, continuously serves requests. The only thing that get disruption is when you have SMB connections. SMB2, SMB3 solves this problem, but with SMB2 you have a disconnect. But with NFS3 it works fine, and with HDFS there is also no problem because it's stateless. So from that perspective, upgrade on an Isilon is very much transparent. Right. And again, I think that's the biggest advantage, is independent on the upgrade of your Hadoop cluster, right? Because you don't need to touch the data when you upgrade from one version to another. Okay, so we run pretty much out of time, and we have a booth here where we also do demos and can discuss further questions, and we would like to welcome you on the booth and show you something that has more depth and breadth than I could bring here in 40 minutes. Thank you very much, and enjoy the show. Thank you.